Okay, so here it is. Only a handful of days left until the final exam. So we are going to start reviewing, and today we're going to review Unit 1, which was line segments. So there were a few formulas that you needed to know for this unit, and the first one was the length formula. So the length of AB has this formula. Now you have to be given 2 points. So with this point, this is x1 and this is y1. This is x2 and this is y2. So when you substitute it into the formula, when you're going to subtract the x's here, so 5 subtract -4 squared, and -2 subtract 3 squared, and it's the square root of that. So 5 subtract -4 is 9. -2 minus 3 is -5. 9 squared is 81. 5 squared is 25. And 81 plus 25 is 106. Now you can either leave it as the square root of 106 or you can work that out in your calculator. So that brings us to the midpoint. The abbreviation for midpoint is a capital M with a little ab, so that's the midpoint of AB. And to do that, it is the average of the two x coordinates and the average of the two y coordinates. So we have -4 plus 5 and 3 plus -2. And since it's a coordinate, make sure you've got those brackets going around. So -4 plus 5 is 1. 3 plus -2 is also 1. So our midpoint is at half-half. So you're going to leave your fractions as fractions. You also had a formula for slope. The abbreviation for slope is a lowercase m with a little ab. And you should know that by now. y2 minus y1 over x2 minus x1. So in our example, it is -2 minus 3 over 5 minus -4. That's -5 over 9. Again, keep it as a fraction. Just make sure it's in lowest terms. There was also a formula for the equation of a circle. The center had to be at 0, 0, and the radius had to be at 4. And the equation for that is x squared plus y squared equals r squared. So all you really have to do is substitute in that radius into the r. So that would be x squared plus y squared equals 4 squared, which is 16. And that's all you have to do for a circle. Now, a perpendicular bisector. Let me just remind you what that is. If you have a line segment with endpoints, what you do is you find the middle point, which is the midpoint, and to indicate that's the midpoint, you put equal ticks on both of those sides. And then what you do is you draw a line that is perpendicular to that line. And to indicate that something is perpendicular, you make that right angle symbol. So that is a perpendicular bisector. So since we are trying to find the perpendicular bisector of AB, the first thing we have to do is determine the midpoint of AB. So that's using the midpoint formula. So let's average the x-coordinates and average the y-coordinates. So that becomes -6/2, -12/2, which is -3, -6. So that's the midpoint. So that's that point right there, -3, -6. The next thing we need is to know that since this line is perpendicular, it has the opposite reciprocal slope of AB. So we need to calculate the slope of AB. That's the second step. So the slope of AB is y2 minus y1 over x2 minus x1. So that becomes 2 over -12, which is -1/6 in lowest terms. And the third step is we need the slope of a perpendicular line. So that's the symbol there for the slope of a perpendicular line. So it's the opposite sign, so it'll be positive, and this is flipped upside down, so our slope is +6. So now to find the equation of that line, we have the slope and we have a point that it passes through. So now we use, for our fourth step, the equation of a line. Y equals mx plus b. So we've got the slope. We know the slope is 6. What we don't know is the y-intercept. So we're going to substitute this in for x and this in for y so that we can solve for the y-intercept. So the y is equal to -6, the slope is 6, the x is -3, and we're going to solve that for b. 6 times -3 is -18, and if you add 18 to both sides, that is equal to 12. So the equation of our perpendicular bisector is 6x plus 12. Now we also did medians and altitudes, so you can take a look at your notes from Unit 1 to go over how to do the altitudes and the median. Question number 4 is you having to verify geometric properties. So one example is we have to classify this triangle here as scaling, isosceles, or equilateral. And we do that by looking at the lengths of each side. So the first thing is we're going to find the length of PQ. So there's your length formula. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, you can leave it as a square root. So that's one length. I'm going to find the next length, which is QR. X2 minus x1 squared plus y2 minus y1 squared, and the square root of that. So that becomes -2 squared plus that becomes 3 squared. All right, so we have at least two side lengths of different, or two sides of different lengths, so it's not equilateral. But you have to find the third side, which is RP, to see if it is isosceles or scalene. All right, so they're all different lengths, so that means it's a scalene triangle. Unequal. You may also have to verify properties using slopes. So this is asking if this triangle is right angled. So what we're going to do is look at their slopes so that if any of the slopes are negative reciprocals, then you have a right triangle. Okay, so this is going to be a little hard for me to do to see it on the page. So I'm going to do it up here and then move it down here. So the slope of PQ is y2 minus y1 over x2 minus x1. And that becomes -4 over -6, which is 2/3 in lowest terms. So I'm only writing it up here so that I can see the points. You should be writing it underneath. So the slope of QR, y2 minus y1 over x2 minus x1. Oops, that was a -4. So that becomes 3 over -2. And you can stop right now because we've got 2 over 3. We have 3 over 2. Therefore, this is right angled. Because two slopes are opposite reciprocals. And that means two sides are perpendicular. Okay, so that is Unit 1. And like I said, all this work should actually go down here. That's Unit 1. It's mostly about slope, length, and midpoint and verifying geometric properties. You got this circle thrown in there for some reason. Anyway, if there's anything you didn't understand, ask your